Hello to you who are willing to learn Python programming language. Thank you for being with me in another educational video of this popular programming language. We go to the discussion of filtering sequences elements. Suppose you have a series of data in a sequence and you want to run a series of processes on them. For example, you want to apply a dimension reduction processing or any other filter on them. There is a discussion called list comprehension. Consider the list L here. Let me write it here for you. List comprehension. Okay. We want to have a list here, for example, which is named L with some data in it. These are not real data necessarily. We are here to practice. Okay. We want to say, we want n's for the case that this n is inside L and is positive. For example, positive. This is a kind of a filtering. We can say we want n for n in L if n is greater than 0. Okay, what is the problem? This is equivalent to, let me first okay, let me first do this, explain this to you. This is equivalent to we have L2 list, an empty list actually, and say for n in L if n is greater than 0, L2 that append this n, and finally we want to have this L2. And you can see that here, but what is the problem with this one? We want n for n in L if n is greater than 0. Let's have it inside the list, and again, okay. The problem was that these kinds of expressions should be inside a list in order to be able to be shown. Okay. This is not very professional to use these multi-line codes, but the summary form is as follows. This one-line code. You can see that the outputs are the same. We can write the same expression for n less than 0. You can see the same expression here. Instead of greater sign, we need less sign. Okay. So you can see that this list comprehension is a very effective method, but the problem is that if the input dimensions are large, the output will be very large too. In these cases, an expression generator can be used. For example, we can say for I in P, for example, print I. Actually, here we did not define this P, but I just wanted to show you how this expression generator works. Actually, we will talk about this concept in more detail in the following lectures. In such a situation, the extraction of elements from the filtered data can be facilitated. You can use the filter built-in function, and this filter receives a function and an iterable from you. Let's have this website of Python documents, and we want to see the filter built-in function. You can see that this filter receives a function and an iterable from you. That is, it applies a condition on the elements, and if they pass this condition, it returns an iterator. So if you want to view if you want to see the output, you should put the output in a list actually. For example, consider we have a list which is named well, and this contain some string format of some integers. Actually, these are also some non-integers which are in the string format to here, and we want to ignore them in the process of this filtering. Okay, consider this list here. Back to the Python, we want to say filter built-in function. Let's say, can we find this built-in function here or not? Let's say that if this kind of syntax searching will work. Okay, this is what we want. You can see that there is a built-in function receives two input from you. One of them is a function, the second one is an iterable, and it returns an iterator to you actually. Okay, you can read any information about this built-in function here. Back to our list, well list. Actually, we want to convert these string values to integers. So what happens if we use a list comprehension? For example, consider we want to say we want the integer format of n for n in this well list, and you can see that there is an error. We get an error because the interpreter cannot do such a thing with a series of these elements. In these cases, we must add some other conditions. It is better to write a function for it. For example, consider function def is int with an input argument, for example v, or we want to have a try exception block if x can convert to the integer format, then return us true. Exception, what is the exception? Except, what is this error? Value error. So we write it here, value error, return us false. Okay. What, it did not change the color. Okay, the color change is applied here, and now we want to use the filter built-in function here. The first input argument is a function which is the same is int here, and the second one is the iterable sequence actually, and you can see the output something like this. It's an object actually. This function returns the iterator in cases where the result of the isInt function is true, and in cases where the result of this function is false, it removes that element. So if you want to see the output, you must call this function inside the list. For example, you can have an expression like this, a list format of calling this filter with the same isInt function and the val iterator, and you can see the result. Okay, consider another list which is named num, which contains some numbers, actually positive numbers and negative ones. Suppose you want to filter the elements of this list, and this filtering is to take the square root of these numbers. Actually, at first we need to import the math. Okay, and we want to have math.sqrt n for n in num if n is greater than 0. Okay, we need to consider the condition of greater than 0 because in order to have the square root we need a positive number. With this statement, you simultaneously check the conditions and apply the desired task to those conditions. In some cases, we don't want to remove actually we don't want to only remove those elements that don't meet the conditions. Sometimes it is necessary to replace these values with other values. For example, let's have n, we want to end if n is positive, else I'll put 0 for n in this num. You can see that it is working, and we can see the same syntax for negative numbers too. Another interesting method is to use itertools.compress. Suppose we have data, we write it as a list. For example, suppose we write people's name in it. Consider the data 1 as a list of people's names. For example, Ghazal, John, Mary, Hillary. Let's scroll down to place in the screen. Okay, this is our data one. These are names of peoples, and at the same time consider the data 2 list containing numbers 30, 24, 27, 31 and 25. These two lists are corresponding, and data 2 contains the ages of people whose names appear in the data 1 list. We want to have the age older than 25 among these ages and have the corresponding person's name. What is the best method? Let's do it from Ether Tools, import compress. Let's have more than 25, for example, a variable of more than 25 which contains the value of this expression, the ends or which are greater than 25 for n in data 2. Let's show this more than 25 here. You can see that these are some trend of falses. Now we want to match this result with these names. Compress also returns you iterator. Let's use this compress data 1 more than 25. You can see that this is another iterator. These are very helpful in specific situations and real examples to understand the applications of these. I strongly suggest that you don't neglect the machine learning and deep learning courses available in Udemy. If you want to see the result, you can apply it inside a list, and you can see the output in this way. Okay, we go to the next discussion, that is extracting a subset from a dictionary. We want to have a topic, so let's go on a markdown mode, consider a square sign and a space, and write the topic here. Extracting a subset from a dictionary. You can see that is we have an initial dictionary and we want to have a subset, for example containing some keys, or for example only containing some values of the initial dictionary. For example, consider the dictionary D containing the names of companies and their stock values. Dictionary D, for example, okay, these are the names. For example, ASR and the stock shares, for example, something like this. M and B, another company's name, and the price would be, for example, 41 and 0.2. Another name could be OLP, or with the stock price, for example, 65.30. Another name could be RTC with the stock price Let me a point is missed here. Here we want to have this. Okay, and the last one, for example, AZR, and the price is, for example, 74.5. Okay. There are different ways to make a sub-dictionary from this dictionary. A very simple method is to use the built-in dict function itself. For example, we write a dict format of a tuple A and 5 and B and 6. Okay, a parenthesis is missed here. Okay, this is correct. We want to have companies whose share value is more than 41.5 in a dictionary. Let's have the first solution here. Solution 1. Consider this D1 as a dict of a key values pair for key and value in D dot items if value greater than 41.5. Okay, now let's show this D1. This solution actually uses a sequence of tuples, but this is not the fastest way. The fastest way is to use dictionary comprehension. We had a list comprehension, and here we want to get familiar with dictionary comprehension. Okay, now let's consider the solution 2. Okay, actually we want to write it here. Consider the same D1. At this time we act like this, and value for key and value in the dot items if value is greater than 41.5. Okay, and finally at this time we want to show this D1 again, and you can see the output. Suppose we make a set with company names. For example, this set is named as names, and the names are OLP, RTC, and for example AS are not AZR. Okay, here we choose a series of names excuse me. Here we choose a series of names, and we want to make a dictionary with what keys? We want the keys to be the same names in the names set, and the values to be their corresponding values in the dictionary D. There are different ways. The first way is to consider this D2 as, for example, key and D of this key, the value of this key in the D dictionary for key in D dot keys, and names. Remember that this and was one of the operators among sets. Okay, let's show this D2. We have already said that the keys support the operation of sets. There is another way that is faster than this. We want to consider another D2 again, and this time we want to act like this: key and value for key value in D dot items if a value is greater than 41.5, and again we want to show this. Okay, let's put double percent time it on it. You can see that this is what this keyword time it shows to us. Actually, this at the time of running the code. Let's write the same expression above the second code, which we said that this second code is faster. Wow, such a surprise. This one was faster. Okay, this is correct. And the second code is faster than the first one. You can run the cell many times, and you can examine, you can check that if the claim is correct, and actually the second one is faster than first one or not. The time it result is the average plus a standard deviation of code execution time, because if this keyword is used, the code will be executed, will be run actually many times, and the average running time will be returned. If a double percent time is used, double percent time, this is double percent time it, and we can also use double percent time is used. The code will be run once, but if an expression is written in the code which has an output, it will also show that output too. A double percent should be used for multi-line codes, but a single percent sign can be used for single line codes. Even the comments should not be before this time keyword, otherwise we will get an error. The next discussion is the mapping of names to sequence elements. So let's go on markdown mode, insert a square sign, consider a space, and write the topic, which is a mapping of names to sequence elements. What does it mean? Accessing a sequence elements based on their position makes the code hard to read. In addition, if you want to change these elements later, if an element is added or subtracted, the position of these elements will change. So this is the issue or problem that may arise. What is the solution now? You can access the elements of a sequence using their names instead of their positions. We have already talked about collections. Among the features of this module, we need named tuple. Let's import them from collections. Import named tuple. Okay. This function takes two inputs from you. The first one is a typed name, which will later become a subclass of the tuple. Look at it like a noun. The second is the fields you give it. Let's try it together. This is the user as an object of this named tuple. The first argument is the tuple subclass user, and the second one is the fields, which is actually a list. F name, L name, this should be in a string format, actually a programming language, and for example age. Okay, now you can create a tuple with these four members using this user. We define this user as an object of this subclass user, and give the values to it. غزل، لالوها، Python, and for example 30. Okay, let's show this user. So in this way you can access the elements. For example, you can have this user F name, this user L name, this user, let's scroll down, this user programming language, and this user age. Okay. Now you can add fields to this tuple, and this layout will not change. These are subclasses of tuples and support tuple operations. Let's see what is the length of this user, and you can see that this is 4. We can also act like this because these are subclasses of a tuple. We can access the elements like this user. Now we can call this features F name, L name, programming language, age. Okay. Suppose you have a list or tuple containing your employee information. This information indicates that this employee has a monthly salary of $9,000. He has to do one additional project per month as part of his work duties, which takes 24 hours to complete. He will receive $360 per hour for this project. So consider this R as a tuple. For example, 9,000, a constant salary, 24 hours of doing the extra project, and 360 salary per hour. This is a record you have kept of this person. Let's define a function compute salary with the input argument R. We want this function to return us R0 positional argument, actually accessing R1 multiplying R2. Now let's apply this compsel function on our record R, and you can see the result. Now if we want to change this record and add some features to it. For example, the first name and last name of this person, which would be added, and again we want to have the same function definition here, and again we want to call this definition with this r this time. And you can see that the output would not be applicable since this time the r0 is this ghazal, and the r1 is this laluha, and the r2 is this 9000. So the output is this, and this is not the salary of this person. This is confusing. You can see that the computations must be changed. Let's define this function for computing the salary differently. For example, this should be R2, this should be R3, and this should be R4. And this time, if we call this compute salary or with the same input argument R, you can see this is the correct result. Let's try the better solution. Let's use this named tuple. Let's consider W as an object of this named tuple. The first one, the subclass, and the second one, a list of fields. For example, constant salary, hours of doing the extra project, and salary per hour for doing the extra project. Okay, and now we want to consider the small w as an object of this w with the values 9000, 24, and 360. Okay, and now we want to change the definition of this computing salary function. For example, with the input arguments of t, we want this function to return us t dot constant salary plus t dot hour multiplying t dot sph. Okay, and now we want to call this compute salary with the same small w, and you can see you got the correct result. This is actually keyword argument. Now if we change this w, for example, we have the same object definition of this named tuple, but here in the fields we want to add a first name and a last name too. Okay, and again for value initialization we need to have copy it, paste, and here we want to add the first name and the last name of this programmer. Okay, now again, if we call this compute salary with this W, you can see that the result, the output is correct. You can see that there is no need to make new change in the calculations because the elements have names in this case. So this is the advantage of using objects that you work with their names. A subtle point is that where you need a dictionary, you can use a named tuple, because when you use named tuple, it is as if you connect a key to a value. Dictionary occupies more space than named tuple, so using named tuple is associated with memory optimization. Although in some cases the use of a dictionary is unavoidable, in some other cases the presence of certain complications prevents this replacement. But for example, in cases where we have large dictionaries, this replacement is very efficient. Just be careful, if you want to change the values in the dictionaries, you can no longer replace them with named tuple. Why? Because these are immutable like tuples. You can use the replace method to apply this change. For example, consider in this case a W dot salary per hour. For example, we want to change it to 0.3. You can see that this is an error. We can get an error. But if we do define another W is equal to W dot underscore replace salary per hour, this time is equal to 0.3, and this time show the W. You can see that the salary per hour has changed, and this time we do not get any error. Actually, this replace method creates a new tuple. An interesting application of this method is when you have created an empty tuple and want to fill its elements using a dictionary. Actually, you want to put the dictionary keys and the values into the tuple. For example, in this example, consider this W as an object of a named tuple, the instance W, the list of fields F name, again L name, again a constant salary, again hour, and again salary per hour. Okay, and we want to have an instance of this subclass W, and this is actually an empty tuple to empty a string, and 0 as the others values. Let's show this W, and you can see that this is empty. Suppose we have the dictionary D, which is, for example, F name Ghazal, L name Laluha, and constant salary, for example 1000. Let's scroll down. our 40, for example, hour for the extra project, and salary per hour for the extra project, for example, $720, something like this. Now we need to define another function which is named dictionary to named tuple with the input argument age. The input should be a dictionary. We want this function to return us w dot, applying the replace method on this w with any number of input argument in this dictionary. The input of this function is a dictionary. Replace works with keyword arguments, and double star h enters the desired number of keyword arguments in parentheses. Now let's call this new defined function dict2 named tuple with the input argument d, our defined d dictionary, and you can see the output. Here you can see that our w are filled actually with these values of the dictionary D. Okay, thank you for being with me in this video. Stay tuned as there are key and valuable tips in upcoming videos that will help you become a more professional programmer. Have a nice day.